So I'm delighted to be here to discuss DNA in your family history research. I've been following how DNA could impact genealogy since the early 1990s, which was essentially when I got into doing genealogy myself. The impact of DNA in family history has certainly exploded over the last decade and even few years. And this talk aims to discuss much of the background behind the test out there and how this can be used in a practical sense as a family historian. Since 2003, our magazine, American Ancestors, has published a quarterly genetics column, and I've edited this since 2008, and I'm always interested in talking with people if they might have a column to write. Now, DNA serves as a very valuable tool in our family history research, but I do want to stress that it doesn't replace family history research. Some of the information that we can now learn from DNA, such as our patrilineal or matrilineal migration patterns, probably could never have been known from paper research alone. So some of this information that we do get from genetic tests are fascinating, not just from a genealogical, but rather from an anthropological point of view. Now, I do want to just ask, how many here have taken a DNA test? All right, so a good amount of you. How many have taken a mitochondrial DNA test? How many have taken a Y chromosome test, or if you're a female, had a brother or so forth? And how many have taken autosomal DNA tests? All right. So you might want to consider a DNA test if you sort of want to have a line that you want to confirm, you want to test out a hypothesis, or just simply curious. A DNA test is not going to be applicable in every genealogical hypothesis. And as I explained the basics of the tests, it's pretty clear that the most useful DNA confirmations usually occur with trying to prove the paternity of a male ancestor or the maternity of a female ancestor, although now at this point there are some other tests out there that have given us some additional options. So I'll start by going over some basic principles of how we obtain our DNA which contain hereditary material. Certain types of markers are used by the DNA companies for comparison between other participants and total population groups. While your own DNA does not change, how your DNA could be interpreted may change with additional technology. And all of these companies are only as good as the number of their participants. More are going to join over time. So perhaps you might not get the match you were looking for today, but you may get a match that could mean a lot in a few years. And I took my very first DNA test in 2003, and it took me about 4 or 5 years before I got any real meaningful matches. The first types of DNA tests that are genealogically useful that I'll discuss are mitochondrial DNA and Y-DNA testing. Now, mitochondrial DNA is inherited from mother to child. So males have mitochondrial DNA, but they do not pass it on to their offspring. So this chart, the females are in red. Essentially, the mother at the top has 3 children, 1 son and 2 daughters. And then when we get to the 3rd generation, her grandchildren, her mitochondrial DNA is only present in the children of her daughters. The children of her sons have their mother's mitochondrial DNA. How mitochondrial DNA has been used in genealogy is largely when you're doing your matrilineal line, your mother's 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 line, or comparing 2 people that could be matrilineally related. mtDNA is not part of our nuclear DNA, so it has nothing to do with how we physically appear. It's actually cytoplasm just outside of our nuclear DNA. Sometimes it gets called junk DNA, but that's kind of a misnomer because there are mitochondrial diseases and whatnot. But I mean, the main thing to know about mitochondrial DNA is that it's separate from our DNA chromosomes, and because it's only inherited from the mother, it has a very gender-linked pattern of inheritance through women only. Also, I would point out, and this is not really relevant when we're doing our family history, but as today we do have newly created families through a variety of means, including surrogacy and test tubes and things like that. Depending on a process of a baby that's brought into the world that way, sometimes children might have the mitochondrial DNA of the delivering mother and not necessarily the biological mother or some combination thereof. That's not often, we don't really need to worry about it when we're talking about our ancestors in the 1800s when test tube babies weren't really popular, but just something to also kind of be aware of as we're doing genealogy and DNA into the future. Also, mitochondrial DNA mutates at a fairly slow pace. So if one is doing a very specific mitochondrial DNA study, there's also what I would call mtDNA full sequence tests that are out there that cost a little bit more. But if you were just to take this test out of sort of curiosity, your basic mitochondrial DNA test will do. Now, our mitochondrial DNA is essentially able to trace our populations back to the earliest human populations. Our most recent matrilineal ancestor to every present-day human, she's believed to be a woman in Eastern Africa around 120 to 150,000 years ago. She would not be the first female human. She and her peers would have had their own most recent matrilineal ancestor and so forth. She's simply the last person that the world's population descends from through women only. Essentially, the way that these through following these matrilineal descents, there's haplogroups, and the first haplogroup is haplogroup L, which is the group that starts out there in Eastern Africa. And essentially, the migration patterns start out with within Africa, all the groups are L or M, and then groups go through the Middle East, and some groups follow into Europe, and then other groups into Asia, Australia, Polynesia, and then prior to 1492, essentially your most recent arrival of or migrating matrilineal group is Native Americans via Asia through the Bering Strait. So all these migration groups have distinct haplogroups. So I'm going to give a brief little overview about what exactly is a haplogroup. So a haplogroup is an ancient ancestral grouping that shows particular migrational path that your ancestors traveled out of Africa. Or within Africa. So as these groups or haplogroups traveled across the globe, they became isolated from other groups. Within these new environments, conditions and diets changed over tens of thousands of years. So the DNA of each haplogroup eventually became different due to adaptations needed to survive in the particular environment, and therefore they became genetically distinct groups from one another. And I'd want to point out what they are testing and how they determine your haplogroup is an extremely, and all of these DNA tests in general, they're an extremely tiny amount of our overall human DNA. It's a very, very small portion that they are able to test all of this information about. The bulk of human DNA is 99+% the same for every human that is tested, but these are very specific types of tests that do have this genealogical or migrational component. When you take the test, essentially, with any of the major companies, and I'll explain the companies a bit later, you'll be provided your mtDNA haplogroup with some explanation about its origins. So for example, my daughter's haplogroup is L2B. What they generally say is that this group arose about 30,000 years ago in Western or Central Africa, and it's spread outside Africa primarily through the slave trade. In our situation, my daughter's ancestry is from the Caribbean, so that we presume that it would have come over at some point in the 1600s. Further, when you test further markers along the mitochondrial DNA, you can get a little bit more specific to possibly a specific portion of Africa, and that also, or Europe or wherever, but that also depends on the people who have also chosen to participate and people that they have tested. So that's how you might get matches later on down the road. Now, the other bit of DNA that is genealogically useful is Y-DNA. So the nature of how men are men and women are women, men have the sex chromosomes XY while women have the sex chromosomes XX. And because of that nature of inheritance, only men have the Y chromosome. And so this is a type of test that only men can take. Essentially, a man receives his Y chromosome from his father, who received it generally unchanged from his father, who received it from his father. So essentially, it's this spur of Y-DNA inheritance from your patrilineal line. Now, one thing that I've often kind of get is, why can't you test the X chromosome? And there's some people sometimes get confused between the X chromosome versus the mitochondrial DNA that I had gone over. The X chromosome is not the same as mitochondrial DNA, and you can't really use it in the same genealogical component. The way the X chromosome essentially gets recombined largely each generation. So For me, I have a full X chromosome from my father's mother, and then I have a combined X chromosome from my mother's two parents. And because of this nature of the only part of my X chromosome that is not representative of any of my ancestors is through my father's father, because I only have his Y chromosome. Because of the nature of how the X chromosome gets recombined every single generation, while you can test the X chromosome, it's not specifically gender linked. So it's not as genealogically useful in that regard. Although these charts here sort of show you how the potential ancestors that might have a part of your X chromosome. And it's different for men and it's different for women. So the basic thing to remember is that you are not going to have, your X chromosome is not going to be representative of any of your male ancestors' fathers. So the general catchphrase I said is 2 men in a row, the X is no more. So, but I have had some interesting examples in articles where we actually were able to use the X chromosome in kind of a more genealogically useful manner, but essentially we can't use it to the same strategy as we can the Y chromosome. But when you do take a Y chromosome test, and at this point Family Tree DNA is really the only company that does Y chromosome testing to a degree, you're going to get a level of markers. And at this point, Family Tree DNA offers 12 markers, 25 markers, 37, 67, and 111 marker tests. And they range anywhere from about $79 to around $350, $380. Each level of markers are going to mutate at a slightly faster pace. So if you have, if you match someone at 12 markers, your common male ancestor could be 800 to 1200 years ago. If you match at 25 markers, it could be 400 to 700 years ago, and so on. All of these are sort of mathematical probabilities based on their research with seeing how test participants have matched to each other with known patrilineal ancestors. So basically, Y chromosome tests are best for researching your patrilineal ancestry, often kind of one-name study projects to see if people with a given surname might be related to other people. And amongst countries that have had established surnames, they've been useful for comparing either immigrants to the New World or common progenitors with a surname to see if they are related to other individuals. My own example where I have traced this, so for in my ancestry, I have traced my patrilineal ancestry 14 generations. It's here in Massachusetts with then 2 generations in England. My ancestor came in the 1640s, and he had a few first cousins who also immigrated to Massachusetts. We've had modern-day descendants of my ancestor, me, and then those cousins' descendants, and all of us have matched. And our last common ancestor is 14 generations ago. Sometimes this has also been helpful for people who might have a brick wall ancestor and maybe they only know their patrilineal line back 5 or 6 generations. But if they match with people who have more known and documented patrilineal lines, that might give them some direction to go for in figuring out where their ancestry might lead back to. Now, I'd also like to point out that you shouldn't necessarily, when you get your results, don't necessarily jump to conclusions that you're not related to the rest of your family or something like that. That can be a possibility, and I have one example later on that talks about that. But when I took my first genetic test in '03, and there was a distant cousin of mine out in Utah named Kelly Child, and he and I had talked about genealogy. Our common male ancestor was in the 1740s. We took the test, and initially it claimed we were not a match. We then got a further distant cousin who split off with England. He took a test, and he matched me, but he also didn't match Kelly, according to the initial results. We then got sort of a midway cousin, someone who was a little more closely related to Kelly and still the same level of kinship to me. And this fellow's results, he matched me and he matched Kelly. And essentially what we realized was this seventh cousin of mine, Kelly Child, had what I call the situation of rapidly mutating markers. So once I looked at them with my eye, I realized we had actually 30 out of 37 markers in common, which because of how the algorithms work, that doesn't usually come up as a match because 30 out of 37 would normally not be considered a patrilineal kinship. But this midway cousin had 35 out of 37 to me, and he had 34 out of 37 to Kelly. So Essentially, this was a case, I called it sort of X-Men DNA, where it was just rapidly mutating at each generation. So there's going to be aberrations that occur where you might get something that might not immediately make sense, and so just don't get too alarmed. Try to sort of look at every option before you get that. Also, I'd point out in terms of for Y chromosome studies, there have been some successful cases of figuring out patrilineal origin in Africa, and this has to do with testing people in present-day Africa and testing their Y chromosome sequence and having a very close match. One example that was used there was with the actor Chris Tucker, and his Y chromosome was an East African Y chromosome sequence that matched specifically to an area of Angola. And he was able to meet people who would be his patrilineal kinsmen. And I'd point out, this doesn't necessarily mean that's where in Africa his ancestors came from. It means that's where descendants of his African ancestors live now. So they could have migrated the common ancestors between these two people who have common male ancestors about 300 to 400 years ago in the case of the mathematical probability. Those descendants are there today. So that might have been where their ancestors lived centuries back, or it might have been from some other area. When you do take a test, and similar to the way that you take a mitochondrial DNA test, you'll be given a certain haplogroup, and this migration pattern is sort of similar to the migration map for mitochondrial DNA studies with a little bit more variety. The common patrilineal ancestor to human populations is also in East Africa, but it's only about 80,000 years ago. And then you have the various groups within Africa, and then similar migrations up through the Middle East into Europe, Asia, Australia, Polynesia, and then into the Americas. One thing that's been kind of interesting, if you're just doing this sort of for curiosity, and you do hit sort of what I would say a brick wall in terms of where the written records end, it can be kind of useful just to kind of figure out where they ultimately go back to, at least on those specific gender lines, in testing your mitochondrial and patrilineal ancestry. And this can get a little complicated. So this is the ancestry of Henry Louis Gates, and he's had himself and several different relatives take DNA tests and had all their haplogroups tested. So, I mean, from his own DNA, he knows that his patrilineal line is European, as well as his matrilineal line is also European. And the same went for his father's matrilineal line was European. But he essentially had first cousins, second cousins, third cousins. He had 10 different people take DNA tests, and he's identified certain groups as sub-Saharan African and certain groups as European, because from his genealogical research alone, all of his ancestors are identified as African Americans back to the late 1700s in either Maryland or Virginia. So this gives him some idea, and then within Africa it might give a certain area within the continent that your ancestors might have lived or might have matched up to. And I'm doing this a little bit with my wife's parents' ancestry, and I've started. It's not as complex as this chart. I've gotten about six cousins to participate who might have the all-male line descent of an ancestor or the all-female line of an ancestor. So I'm making a similar chart like this. Now, the next DNA test, and this is a relatively new type of test, but it really has taken off, is autosomal testing. So essentially what an autosomal test is going to do, and this is going to test sort of all of your ancestors, it's going to be testing hundreds of thousands of autosomal markers. So while we're going to get exactly half of our DNA from each parent, autosomal markers are going to derive from our ancestors over several generations. And these tests determine how closely two people could be related to each other by the number of DNA segments they share in common along the numerous markers. And essentially this is going to be comparing our 22 pairs of autosomes. So each human cell has 23 chromosomes and split from their mother and father's cell, with one being our sex chromosome pairing, and the remaining 22 are these autosomes. However, each of these 22 pairs of autosomes involves a pairing of two parents' DNA, which in turn was paired from their parents' DNA. So while we are going to be 50% our father, 50% our mother, we're not necessarily going to be evenly 25% each of our four grandparents. We could have some variety from, say, 27, 23, or something like that. And this will take over several generations. We might lose what I would call genetic fingerprints from some of our ancestors and might have higher genetic fingerprints from other parts of our ancestors. To demonstrate sort of what I would call the randomness of how we get our DNA, this is an example where I had my daughter take a DNA test, my wife and I took a test, and then all 4 of our parents took the DNA test. Now, she's 50% each of us, but she is 26.2% her maternal grandmother, and she is 25.9% her paternal grandfather, 23.9% her paternal grandmother, and 23.8% her maternal grandfather. Essentially, both of our parents add up to 50%, but so the most related grandparent is going to be the partner of the least related grandparent, and then the second most will be the partner of the third most. Well, this is a variation of only 2.5 generation points between the most related and the least related. My mother-in-law was very happy to be the most related grandparent to her grandchild. This test can also be great for comparing close cousins as well as ancient origins. If a parent, and also if you get a parent to provide a sample as well, these tests, and just one parent, not even both parents, because they sort of will deduct the ancestry you inherit from the other parent. You can determine what chromosomes or what origins you received from both of your parents. Now, the tests that I preferred, how they give you the genetic results, and all the companies that I'll mention will all sort of do this to some degree, but I generally prefer the way that 23andMe gives you their specific results. So this is an example here of my father-in-law's results, and they give you the options in chromosome view, speculative view, standard, and in terms of speculative, standard, and conservative estimates. And this is based on genetic material in autosomes that can essentially be assigned prior to intercontinental travel, i.e. before 1492. However, this is definitely not absolute and can definitely change over time. So his ancestry is from Dominican Republic, and it's identified here as 69.5% European. Of that is further identified as 34% Iberian, which we would believe would be largely Spanish. Of that, 18.9% broadly Southern European, and then they even further identify 0.8% Ashkenazi. Then they say 12.7% Sub-Saharan African and 10.3% East Asian and Native American, and 3.7% Middle Eastern and North African, and then they do 3.9% unassigned. I would also say that these results, and I would say this even more so with the results that you'd get from Ancestry.com, I say these are very speculative, especially for populations within a continent, i.e. Iberian versus Sardinian versus Italian. It's not entirely clear how they're getting the material to really conclude what an ethnic population is. I think this is a very good test for within a continental origins and maybe a general area of a continent, Central Africa, East Africa, West Africa. But to be specific to a specific ethnic community, I think based on the whole nature of how we get our autosomes, I think there's some good reason to not take all of this too seriously, and these results are definitely going to change over time. Now, you can also see your results on 23andMe and chromosome view, and one of the things I like about this is that it will tell you what DNA comes from one parent versus the other. Essentially, this has top half and bottom half. Now, the top is going to be from one parent, the bottom will be from the other. It won't tell you which parent, and also the entire sequence of the chromosome is not going to be necessarily the one parent all the way. It might flip-flop along the line. But essentially, this is able to tell me that for my father-in-law, and the results are somewhat similar for my mother-in-law, that he had results that were, both of his parents had European, Native American, and Sub-Saharan African ancestors. Also, if you were to take a test with 23andMe, automatically, if you're a man, they give you the haplogroups, both your patrilineal and matrilineal line, and if you're a woman, they give you your mitochondrial haplogroup. They don't do that with Ancestry.com, and Family Tree DNA does test that, but it's a separate test, not part of the overall test. The next thing that a lot of these autosomal tests will show you is what they call DNA relatives. Family Tree DNA calls this Family Finder. And this is where you could potentially get matched up with close cousins and whatnot. And this is another example of where I would say sometimes a sibling might have a little bit of a different result than the other, and that all depends on the type of DNA that you would get. And I'd also point out earlier when I was showing my father-in-law's examples, especially for people with a multiracial ancestry, siblings are almost certainly going to be having different results. Siblings are only going to be about 50% related to each other. So what DNA they each got from each parent is going to be largely different. There's going to be a lot of differences. So don't be surprised if you and a sibling get different ethnicity or continental origins results. That's not necessarily surprising at all. In this example, I had a match to someone who turned out to be my third cousin. And what was interesting here was for my mother, it predicted they were second to third cousins, which is true. But then for my uncle, they only predicted that they were fourth to fifth cousins. And it just happened that my uncle randomly got less DNA in common with this particular relative. And that has to do with over time. I mean, you can easily lose genetic fingerprints of your ancestors over time, but you'll very quickly lose genetic fingerprints of your cousins over time. Siblings are about 50% related, half siblings are about 25%. First cousins are only around an eighth, second cousins are only around 3% related, so very quickly you could potentially not have much DNA in common with relatives. This is a kind of complicated example where I had two different third cousins, one through my mom and one through my dad. The cousin through my mom, she had the predicted amount of DNA, and then even her son and my daughter had the predicted amount of DNA for fourth cousins. But then this cousin Sean on my dad's side, he shared a little bit of DNA with my father. It was kind of low for second cousins once removed. And then he had a very, very tiny amount of DNA with me, and we're third cousins. And then when it went down to my daughter and him had no DNA in common at all. So very quickly, just within common great-great-grandparents, someone who was a third cousin once removed lost genetic DNA that was in common with a particular relative. And there was nothing, I mean, everyone was the child of so-and-so, and the DNA generally did show that, and there's other cousins that were also in common, but my daughter had DNA in common with a fourth cousin, but no DNA in common with a more closely related third cousin. Now, in terms of how you can take a test, if you've taken the test before, you know this. Most of the, besides family tree DNA, this is generally done as a saliva test now, sort of spitting into a vial. Family tree DNA generally does this as a spit cup. I'm sorry, as a cheek swab. That's the way they take a test. Some of the years ago, you had to do blood. That hasn't been around in about 15 years or so. One company that's since gone under was Sorensen Genetics out of Utah, and they had a mouthwash that they called Genetirinse, which I thought was kind of cute. It's a pretty it's not an invasive type of test, so it's pretty easygoing. Generally, most companies will say don't have food or drink for about half an hour to an hour before taking the test, so I generally recommend take it right as soon as you wake up. Don't have your coffee or anything. In terms of some of the companies that exist, now there's a lot of smaller companies that exist, but the major companies that exist at this point in the game are Family Tree DNA, Ancestry, and 23andMe, and at this point now, MyHeritage is trying to make a footprint in there. There are some smaller companies, but probably if you have tested with one of these smaller companies, most of the time those are actually being tested by Family Tree DNA. They actually are a very large subcontractor to a lot of other genetic tests. So if you sent your kit to Plano, Texas, it's a company that is sort of subcontracted out by Family Tree DNA. In terms of what each test offers, all three of these tests will offer these autosomal tests and ethnic origins tests. Some of it is sort of figuring out what exactly you are trying to do. Is this just for curiosity, or is there something specifically that you're after in terms of testing out a hypothesis? Family Tree DNA is the only one currently that does this whole mitochondrial DNA test and Y chromosome test very specifically. 23andMe will give you the haplogroups, but that's it. They won't give you the specific markers along your test. And Ancestry used to do those types of tests, but they stopped doing that several years ago. You can also sort of browse the company's databases. I used to recommend this when people were interested in doing surname tests to see, because Ancestry used to do this. At this point now, family tree DNA is really the only game currently that does do this. So generally, if you're trying to do Y-DNA markers, do family tree DNA, the cost of these tests, autosomal tests, range anywhere from $59 to $99, depending on sales at the moment. These other specific mitochondrial DNA tests start at $59, and the Y chromosomes around the same price, and they go upwards to $400. There are a few options to share your results across other sites. These don't have as much meaning anymore because there's only one company that does Y and mtDNA tests, but years ago there were about 6 or 7 major companies that did do this. Almost all of them were bought up by Ancestry.com, or bought up by a company that then was bought up by a company that was then bought up by Ancestry.com. And at a certain point, Ancestry allowed these results to be searched, but they have since stopped it entirely. And that's relatively unfortunate. Some of these people who might have tested might be deceased now. If they had uploaded their results onto the site called Y-Search, that is a sort of third-party way to compare your Y-DNA results, and they also have a result called MitoSearch, but this is really only going to be for people who might have taken these tests 6 to 7 years ago, before when all these other companies existed. In terms of sort of the best, after figuring out your results, there's a lot of these companies will help you test your results online. The major place that I go to for a lot of additional information about what this all means and what things might mean is the ISOG website. This is the International Society of Genetic Genealogists, and they, in my opinion, have the most fantastic information about further data on your results, often more so than the sort of help supports on the specific genetic websites. They'll get into a little bit more detail. And often when you're interpreting your results, this is really going to vary based on the amount of matches that you receive. If someone does not have any close matches, there is very little interpretation. How someone interprets a Y-DNA match may need to be considered with genealogical research. So I generally say if you're taking an autosomal test, this is going to be effective for your ancestors and relatives for the last 3 to 5 generations. If you're taking a Y-DNA test, start at the 37 marker level, and this can be helpful for your line back 10 to 15 generations. And then mitochondrial DNA test, generally that's a curiosity test unless you have a very specific hypothesis, and then you would want to do a full sequence test. Another fun thing that you can see is, on 23andMe at least, is how much Neanderthal you are. Scientists had thought this group of humans had died out, but now there's some indication that they are ancestral to the human population, but on a very small level. So the average 23andMe user is about 2.7% Neanderthal. My father, in this case, was the least of our relatives at 1.8%, and my mother-in-law was the most at 2.4%. This can have some fun conversations over the holidays or whatnot, but it's just kind of for fun. There's nothing to take seriously. Now I'm going to go through a few case studies that involved a lot of these types of DNA and some conclusions that have come about. One of the earliest cases involving Y-DNA and how it was used was the case of Thomas Jefferson and Sally Hemings. Generally, this got reported in a newspaper in 1802 by James Thompson Callender that Sally Hemings, one of Jefferson's slaves, had several children by then President Jefferson. He never really made much public commentary about the matter, and Sally Hemings and her children are the only nuclear family that Jefferson ever freed. Later, some of Jefferson's white grandchildren claimed that Jefferson's nephews were the fathers, and there was a very little historical validity to what they were saying. They had a lot of confirmed lies in what they were saying, but this narrative generally got accepted by historians for the next 160 years. Hemings' second youngest son, Madison Hemings, gave a memoir in the 1870s, and nearly everything he was able to say based on firsthand knowledge was largely confirmed with private papers of Jefferson's and things like that. They did DNA tests that were reported in 1998. And these sort of gave some interesting results. Now, it's also important to understand what they were after in terms of these DNA tests. This was a Y chromosome test since they weren't testing any deceased people. They were not digging graves for this test. So Jefferson, by his wife, only had surviving daughters. So his white descendants were not used for this test. And he only had one brother who left no surviving male line descendants. So they actually got descendants of his father's brother to determine the Jefferson DNA. And then with the Hemings family, it gets a little further interesting. So Sally Hemings was the half-sister of Jefferson's wife. Jefferson's father-in-law had 6 children with her mother, Betty Hemings. And she herself was the daughter of an English sea captain and an African slave. So Hemings' children themselves were of 7/8 European ancestry and only 1/8 African ancestry. So 2 of the 4 at the age of 21 simply apparently moved to Washington, D.C., Maryland with Jefferson's financial support and assumed white identities, changed their names. So we don't even know anything about those descendants. The youngest 2, who were freed in Jefferson's will, they also married free African-American women from Virginia, and they moved initially to Chillicothe, Ohio. But then the younger son, Eston Hemings, he and his wife, who was presumably of a similar complexion, they decided to move to Madison, Wisconsin, where they changed their name from Hemings to Jefferson. And then from then on, they also assumed a white identity. And the descendant who actually participated, he didn't know he was a descendant of Sally Hemings. He had no idea he had any African ancestry. So the only actual descendant of Sally Hemings, of her children who identify as African American today, is the children of her second youngest son, Madison Hemings. And in that case, they can't do male line descendants because he had all of his descendants today only go through surviving daughters. So essentially what they did was they took descendants of Jefferson's uncles, Uncle Field Jefferson, and took their results. They took descendants of the Carr nephews who Jefferson's grandsons had claimed were the fathers. They took those descendants down to the present day. And then they took descendants of Eston Hemings. And it's actually a very good thing they did the descendants at that point, because the descendant who matched was an unmarried man in his 60s, and he only had 2 other first cousins who were also unmarried in their 60s. So if they hadn't done it at this point, it might not have been possible. Now, there's also this fellow named Thomas Woodson, who had been claimed as the oldest child of Sally Hemings that was conceived in Paris. Now, this was a little tricky because there wasn't really much indication that he was even a child of Sally Hemings, let alone Thomas Jefferson. He lived in the same area of Ohio, and his descendants claimed that he was this child, but there wasn't the same amount of evidence in that regard. So nonetheless, he had plenty of male line descendants, and they tested that. Essentially, what these test results showed was that the descendant of Eston Hemings had the exact same Y chromosome as the descendants of Field Jefferson, essentially establishing genetically, and I'd say even genealogically, there was a lot of evidence to show that he was their father before that point, but establishing that point. The Carr nephews were clearly shown to not be the be the ancestors of the Hemings family. And then for Thomas Woodson, the descendants did have a they did have a European Y chromosome, but it was very different than the Jefferson family, so that also showed he wasn't a child of Thomas Jefferson, but I think he's not even a child of Sally Hemings. Now, the other thing that was kind of interesting along the Woodson descendants was 4 of these 5 descendants all had the same Y-DNA sequence, which was a European sequence, but then one descendant had a sub-Saharan African sequence that was different than the rest of the descendants. So this person had a European sequence similar to his second cousin's, while his own first cousin had a very different Y-DNA sequence. So this is a case where he learned something very immediate. So essentially by taking this test, he learned that either his father of record or his grandfather of record was not his biological ancestor. So that's another thing that can be learned, from taking these tests. Another thing that people have wanted to learn about is if you can prove Native American ancestry through these DNA tests. And generally this is kind of going on, besides the autosomal test, this is going along the same line of paternity of a male ancestor or maternity of a female ancestor. There was one case that was kind of interesting, and this involved French Canadians who were of almost all French ancestry. However, several people who were participating traced their ancestry back to a presumed French woman named Catherine Pollard, who they thought was born in France. Yet her descendants clearly had belonged to, descendants to many of her different daughters belonged to haplogroup A, which was clearly an indigenous haplogroup native to North America. So that got them to sort of re-examine their records, and essentially they went through some of these old records, and they realized actually Catherine Pollard was not her birth name. They found some records that called her Catherine Platte, and essentially they found earlier on that her original name was Etenta du Platte. She was the daughter of a Huron chief who at some point became Catholic and assumed a French name. And this was there in the records, but it's since French-Canadian genealogy is, I would say, one of the easiest places to do genealogical research. Some of these more, fine comb records that other areas we might go through, these records got skipped. So it was a result of taking the DNA test that prompted them to do this type of test. Another test, and most of the articles that we've done in American Ancestors have largely been Y-DNA studies. I'm very happy to point out that now we've done articles that have talked about all these other types of tests. But one of the ones we did 9 years ago, I guess, was on Obama's mother's ancestry. His mother's birth name is Stanley Dunham. Her family could be traced back to a Samuel Dunham of West Virginia who died in the 1820s. And we had 2 possible Samuel Dunhams he could have belonged to back in New Jersey. And it was interesting in this case because these Dunham families were definitely not agnately related, and one of the Dunham families was what I call a new Dunham family. Their original name was Singletary, and they were in Massachusetts, and the second generation was Jonathan Singletary, and he changed his name to Jonathan Singletary alias Dunham. No one's really sure why. He was expelled from Massachusetts and thrown to New Jersey. He had connections with this other Dunham family, which is clearly a Dunham family that goes back to Plymouth, and then before that Leiden, Holland, and then England. But we know through Y-DNA there are definitely different sequences. So he had President Obama has a second cousin twice removed, a fellow named David Lee Dunham, who I spoke with quite a lot out in Oklahoma. And he took this Y-DNA test, and he matched to the Singletary alias Dunham families. And essentially that really we were really able to be sure that their Samuel Dunham ancestor belonged to the missing Samuel Dunham from the Singletary Dunham family, because that family was so new with assumption of that surname that this was really the only way that he could fit in. And all of the subsequent kinships that we had said that Obama had to various presidents and other people actually derived through this connection that we sort of established through DNA. And then one sort of story that involves genetic surprises and where you really do learn something new came in the form of my own family. This was involving an autosomal test. So I've talked about DNA. I talk about it to lots of my family members. I've had all of my parents, my uncles, take DNA tests. My mother's first cousin said he was interested to take a DNA test. And this is my mother's older brother's son. And I said, that sounds interesting because his name is Horton, and I could trace my Horton family we could trace our common Horton ancestors back to Virginia. And we knew before that they were from England. I was kind of curious, were our Hortons related to other Horton families in the United States? So he sort of jumped on full board. He said, yeah, I'm going to take that Y-DNA test that you talked about. I'm going to take the 23andMe DNA test. I said, okay, great. So he takes the Y-DNA result. He takes both tests, and then this gets complicated. He doesn't show any genetic material whatsoever to my mother and my mother's brother. There's just no results whatsoever. He is related to some people that are related to his mother. So I'm sort of kind of nonchalant at this point about what these tests mean. And I recommend that his younger brother take a genetic test, take the same test. So his brother takes the test, and his brother is shown to be a first cousin to my mother and my uncle, and him and my mother's cousin Ed are shown to be half-siblings. So essentially what we learn at this point is that the father who raised him was not his biological father. I do a lot of genealogical research, and the date that his parents celebrated their wedding date, it turned out that wasn't actually the date that they got married. He was born in July of 1937, and they always said they got married in October of 1936, which is conveniently about 10 months before his birth. I contacted the counties in Kansas where I assumed his parents would have gotten married, and they didn't have a marriage license, and I contacted the state, and I got it. They had applied in the faraway county, even though they did get married locally, and they actually only got married about 3 months before his birth. I also then contacted my mother about this, and I sort of learned that this wasn't exactly a secret. My mother, who's 14 or so years younger than this cousin, her mother, she was once commenting to her mother about how Eddie didn't look like his younger brothers because his brothers are all over 6 feet tall and he's only 5'7". And her mother sort of said, oh yeah, well, when Clara, his mother, got married to Alfred, she was already pregnant, and they just decided to, say the child was his. So apparently some people knew this, but no one told my mom's cousin Ed. So, and no one had told me. Sort of, I'm a little bit in the middle of this. So essentially, we've learned that Ed Horton is the biological child of his mother, but by someone, unknown. He has some results on 23andMe where, because I also had his now known half-brother take a test, I can tell that I look at people who match his half-brother. People who match his half-brother and my mom are relatives through their father of record. People who match him and his half-brother are relatives through their mother. But people who only match Ed are related to his unknown father, Mr. X. So he gets some kind of close matches, and some of these people are from Kansas. So that's promising, but it's not exactly specific, because if you have a second to third cousin match to someone, there could be potentially dozens or hundreds of potential people. In this case, the other party website that I recommend sharing your results, and this works fantastically for autosomal results, is GEDmatch. And if you take your autosomal test with any of these 3 companies, you can upload your match to GEDmatch. So in this case, he uploaded them, and he got a match with someone who had tested with Ancestry.com. And this person was predicted to be about a second cousin to Ed, and his daughter was second to third cousin or so. And I contacted them, and they were very, very helpful, and I was able to look at their ancestry. And this person, who was predicted to be a second cousin, I could show through genealogical research, was also a second cousin once removed to his initial match from Kansas from 23andMe. And essentially I determined that they had the same common great-grandparents and great-great-grandparents, this couple, James and Cecilia Brown, who were originally from Louisville, Kentucky, and then moved to Wichita, Kansas. It's still kind of, I can't really be exact in terms of who this is. These are both people who are predicted to be second to third cousins, and Wichita is kind of nearby. It's about 90 miles from where Ed's mother grew up. Based on the amount of genetic similarities, and I'm using the statistics for how you can determine this are often on ISOG, I think that probably James and Cecilia Brown are the grandparents of Ed's father, but probably through children different than the people his matches initially descended from. And that essentially, they had 4 other children who left descendants. And at this point, I have what I call 7 suspects who are alive in 1936 who could be his biological father. All of them are from Kansas. They have 4 different surnames, Brown, Howell, McKiernan, and Wellman. But in 1936, only 2 of them, the 2 Wellman brothers, are living in Kansas at the time. And he had also decided to take that family tree DNA test, but I would point out, when you take it, family tree DNA generally can take kind of long to take their results, so it took about 3 or 4 months before we got our results from family tree DNA. And in the meantime, we had actually done 2 rounds of 23andMe DNA testing. But we get his DNA results, and he matches Wellman. So at this point, I feel I've reasonably nailed down that his biological father is one of 2 men, Robert Wellman or Alfred Wellman. And I researched them, find out what I can find about them. Robert Wellman was unmarried at the time of this conception. He later got married and had 4 children. He had died 20, 30 years ago. And then the other brother, Al Llewellyn, was married at the time of this conception. His wife died a little later, and then he had a second wife, but he had no children through either of his marriages. So what I essentially say is, what I'm going to need to do is contact one of these 4 children of Robert Wellman and ask them if they would like to do a DNA test. And this is going to be results that are, I would say, very close to home. These are going to say you either have a half-sibling that you didn't know about, or you have a first cousin that you didn't know about. So I decided to call one of these persons, and I just called one of the daughters who happened to live in Colorado, Maryland. We talked for about an hour or so. She was delightful, and she said, yeah, no problem, I'll be happy to take a DNA test. And then as we were sort of ending the conversation, she said, well, will this DNA test tell me anything different than the one I just took? And I said, what are you talking about? She said, oh, I just took a test with Ancestry.com. I said, okay, let's do this. And also, when I was talking to Ed, he decided he was also, after he got that initial result from Ancestry to the other matches, he decided to test with Ancestry himself, but he hadn't really been up to date on his matches there. So we went, and Ed and Marilyn were clearly predicted to be first cousins. So that made it very clear that her father's brother was his biological father. We also compared the matches on GEDmatch, which I had sort of gone through and testing out the statistics. Ancestry will tell you the amount of centimorgans and whatnot in common, but they sort of go along the lines of just trust us. So that's one thing I try to sort of be a little more certain about. But nonetheless, we were able to determine exactly who his biological father was, and this really only took us about 4 months. And this, I don't think necessarily is going to be typical, but it's definitely very promising. If you were to ask me if we could do this 10 years ago with no clear leads or anything like that, I would have thought that it was a very, just a needle in a haystack. But I'm finding many other examples like this of either figuring out a non-paternity event where we didn't even know one occurred, or people who were adopted, or people with an unknown father or unknown grandfather, or things like that. So this is, really promising, and he's now gotten to know. So we have sort of an interesting family now at this point. We are his cousins through his father of record, and we have now met his cousins through his father of biology. So it makes for some interesting relatives of relatives. I definitely would recommend if you have something you might consider writing about. I love hearing about articles that talks about a lot of different geographical topics, a lot of different ancestries and things like that. If you have, just even if you're not fully at a finishing point in your DNA, just publishing it, even it can be in print or it can be online, just getting your results out there might spur additional relatives to participate that are needed because they might happen to read about that. And that's happened a lot with some of the articles that we've published. We've gotten additional participation that way. So, sometimes you might be daunted initially, but maybe later on down the road, because you get your information out there, you might get further data. One story I just want to wrap up with that I love to share about DNA regards a person who came into our library about 10 or 11 years ago, and she was adopted, and she was interested to find out if her father had any siblings. She's recently written a book about this, and she writes about me helping her out during this. I identified that her father got married and had 6 children. So I was able to find their addresses, and she got contact, and they've had a fantastic family reunion and whatnot. But she tells me her story about how she learned how this man was her biological father. She's about 60 or 65 years old, and in the late 70s, she contacted her biological mother, and she gave her the name of her birth father. Her birth mother was from the Boston area, and she said her birth father was a college student from the Midwest. She writes to him, and he essentially writes back saying, "It's possible I'm your father, but I really doubt it." And that's where she sort of lets the matter lie for about 20 years or 25 years or so. Then in the early 2000s, she starts reading about CSI and DNA and things like that. And she realizes she has this letter and it has a stamp on it that was licked. And this is not any of the DNA tests that I talk about. This is more of a lab. It's a little more of a costlier process. But she had it taken to a lab, and they said, she submitted her own DNA, and they said with 99.99% certainty, whoever licked this stamp is your biological father. As I said, she met her younger siblings, and later she ultimately did meet her biological father after all of this. She had 6 younger siblings, and she told me she was all excited about meeting them and stuff, and they all like to refer to themselves as number 1 sibling, number 2 sibling. Now they say I'm number 3 sibling, formerly number 2 sibling and whatnot. But she told me that when she met her, when she told the story to her sister remarked, well, that's the last time we'll lick a stamp again. So, thank you.